Welcome to Math 2 Unit 3 review. So we're going to begin with the multiple choice review that was handed out. So I'm going to do these off on a separate sheet of paper. So please have out paper to make yourself notes. All right, number one says to evaluate 3x squared y to the negative 1. So off to the side, I'm going to write the rules that we're using. So the rule is that if you have a to the negative n, this becomes 1 over a to the n. Conversely, if you were to have, for example, 1 over a to the negative n, this would become a to the n, right? So it would move into the denominator if it's in the numerator to make that a positive exponent, and it would move up into the numerator if it's in the denominator. And then recall that it doesn't change the value of a. You notice there's never a negative here anywhere. All right, so all we need to do is evaluate this one item. So we're going to rewrite this as 3x squared over, this is going to drop into your denominator, y. And we could put y to the 1, but there's no need, which is equivalent to 3 times x over y. All right, next one, number 2. Number 2 says enter an expression equivalent to x to the 4th, y to the 3rd, y, all to the 2nd power. All right, I always liked, and they want it to be written, by the way, in the form of x to the m and y to the n, okay? So I always say you always want to use the power to a power rule first. And the power to a power rule tells you that a to the m to the nth power is a to the m times n. Also, there's a rule that if you have more than one item, like ab to the m power, that you're going to make sure that both items are being raised to the m power. So a to the m, b to the n, So you can imagine we're combining these two rules. So if we combine these two rules, and let's say we have a to the m, b to the n, and then to the, say, p power, then we would have a to the m times p and b to the n times p. And that's exactly what we're doing here. So we're going to multiply each of these exponents by 2. So that's x to the 4 times 2, y to the 3 times 2, and y to the 1 times 2. And I know that most of us do that in our heads, but I'm just showing that that's the rule we're using. So that would be x to the 8th, and then y to the 6th, y to the 2nd. All right, the other rule that I'll be using is called the product of a power rule. And that says that if you have two bases that are same, like a to the m times a to the n, that you're going to add the exponents, a to the m plus n. And so I'll add these exponents on my same bases, which is x to the 8th, y to the 6 plus 2, which is x to the 8th, y to the 8th. All right, so the next one, number 3. Number 3 says that we have which of the following is equivalent to x to the 3rd times y to the negative, x to the negative 3rd. So I'm actually going to use this same rule right here that I'm adding my exponents. So that's x to the 3 plus negative 3. And 3 plus negative 3 is 0. All right, so now we have another rule. This is the negative exponent rule right here. The other rule we have is called the 0 power rule. Any number raised to the 0 power is 1, except 0. 0 to the 0 power is undefined. And so this is going to equal, that, by the way, common error, I say any number raised to the 0 power is 1, and students do this. That is not true. X to the 1st is x. X to the 0 is 1. That is not equal. So these are not equal. This entire quantity is equal to 1. All right. Moving on to number 4. Number 4 is quite a lengthy problem, so I'm going to go to a new sheet. Number 4 says select 3 that apply. I know that this question is quite a bit harder on here than it will be on the exam. The idea here, though, is that 64 to the x all to the third power, again this is number 4, we can rewrite 64 as a power of 2. So one way to write 64 to the power of 2 would be, you're thinking what number, how many times do you multiply 2 to get 64? So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So again, that's 4, that's a 4, and that's a 4. 4 times 4 times 4, that's 16 times 4. 16 times 4 is still 64. All right. Okay, so this is the first, and the reason I'm looking for bases of 2 is I'm either going to have to use a base of 8, 2, or 4. You see that they've changed all the bases here. So I need to know which of the following is equivalent. Also, this rule right here, right, it's a power to a power rule. I'll remind you that you multiply those. And so we could have something like 2 to the 3x power. So if we had 2 being raised to a power, it would be 1, 2, 3, 4, 5, 6. It would be 2 to the 6th power. And then all being raised to the 3x power. And so far, I don't actually see that option, but I do see 2 to the x to the 18th power. So if I were to multiply my two numbers here, I would get 2 to the 18x power, which is the same as 2 to the x power all to the 18th power. So I see that B is a true statement. All right, there are no others with a base of 2, but there is a 1 with a base of 4. There's actually 2 with a base of 4. So I'm going to rewrite this with a base of 4. So I see it's 4 to the third power. 4 times 4 times 4. So we'll try 4 to the third power, and then this is all to the 3x power. All right, so 4 to the third power to the 3x power would be 4 to the 3 times 3x power, which would be 4 to the 9x power. And I don't see that directly, but I do see 4 to the 3 squared times x. And 3 squared is 9. And then if I multiplied 9 times x, this would still be 4 to the 9x. So I actually do see that C is a true statement. And then finally, using this same idea right here, that we have, this time an 8. So I'm looking for a power of 8. I'm going to rewrite this and see what base would give me an 8. So I have 2 times 2 times 2, which is 8, and 2 times 2 times 2, which is also 8. So 64 is also 8 squared. And so I could also rewrite this as 8 squared to the 3x power. And I don't see that directly, but I do see 8 to the 6x power, and I know I would need to multiply my exponents here, and 2 times 3 is 6, so that would be 8 to the 6x. All right, this is much more difficult than the question that you'll see on the exam though, but you get the idea. You need to be able to break 64 into bases that you're being given, like 4s and 2s and 8s. All right, number 5. Determine which of the following are equal to 8n squared to the 2/5 power. All right, so this is our rational exponent, and it can be rewritten. I'm using this rule that the nth root of a to the m is equal to a to the m over n. I'm combining that with the rule that says if I have a b to the m power, then both a is being raised to the m and b is being raised to the m. So the first thing I'm going to do is I'm going to go ahead and distribute the squared part. So I'm kind of rewriting it as 8n squared to the second power and then to the 1/5 power, because I just prefer to go ahead and write this right after as a radical. So this is under the radical, right? My nth root would be 5th root of 8 n squared, and this is all being squared. And then under my radical, I would go ahead and multiply each exponent by 2. So I'd have 8 to the second, which is 64, n to the fourth. And so looking at the first one, this is not true. What happened was they did not square the 8. Looking at the second one, this is not true. What happened is they did not square the n squared. The third one is exactly what I have. The fourth one, I'm going to see if this actually reduces. The previous question, as you can see, we used a base of 64. That was 2 times 2 times 2 times 2 times 2 times 2, 6 times. And so this is actually the fifth root of 2 to the fifth times 2, that's 2 to the sixth, which is 64, and then n to the fourth. And then remember that this is a perfect cube root, so it's going to pop out. A perfect fifth root, so it's going to pop out, and I get a 2 on the outside. And then under the radical, and remember it's a fifth root, I have 2n to the fourth. All right, so the two that are equivalent would be the third and fourth ones. All right, moving on to number 6. Number 6 says simplify the square root of 64x to the fourth over 25. So if both of these are perfect squares, which they are, you can go ahead and separate them into two separate radicals. The square root of 64 is 8. The square root of x to the fourth, how many groups of 2 can you take out of a group of 4, which is 2? So you have x squared. And I'll show that again off to the side. I have a group of x times x times x times x. I can pull out one group of x's. I can pull out a second group of x's. And x times x is x squared. And then in the denominator, I would have the square root of 25, which is 5. All right. Which expression is equivalent to 7x to the negative 3? I'm just going to remind you that this is not the same as 7x to the negative 3. Here, the whole thing is being raised to the negative 3 power. Here, only the x is being raised to the negative 3 power. So the rule that we would use is that a to the negative n is equal to 1 over a to the n. And so this portion is going to drop into the denominator. So the 7 will remain where it is. It doesn't have a negative exponent, and the x to the third will drop into the denominator and become positive. Number 8, 146 x to the negative 23. This is actually just like the previous question, right? Just this portion is being raised to the negative 23, and so the 146 will not move, but the x to the 23 will drop into the denominator. All right, flipping it over, moving on to number 9. Number 9, it's the same question again. Only the x to the negative 15 is being raised to the negative 15. The 9 is not, so the 9 will remain where it is, and the x to the 15th will drop into the denominator. Number 10, which is the most simplified form of x to the 1/3 power and x to the 1/6 power. So just a reminder that in order to add the fractions, which we're doing this, a to the m times a to the n is equal to a to the m plus n, but we have a fraction, and so in order to add those, we're going to have to get a common denominator. So we have x to the 1/3 plus 1/6. The common denominator is 6. Both 6 goes into 6 and 3 goes into 6, so we'll multiply this one by 2 over 2. That gives me x to the 2/6 plus x to the 1/6, which is x to the 3/6, which is x to the 1/2 power. And then just to remind you, we're using this rule that the nth root of a to the m is equal to a to the m over n. And so this can be rewritten as x to the first power, and it's a square root. Now remember, we don't write the exponent of 1, nor do we write that. So this is just the square root of x. Again, a square root, it's implied that it's a square root. All right, moving on to number 11. It says Tim is going to simplify the expression p to the 7th q to the fourth r to the second over p to the second q to the third r. What step will he need to use for each variable? So if he's dividing, then the rule that he would be using is that a to the m divided by a to the n is equal to a to the m minus n. So he'll be subtracting the exponents. And so the correct answer is to subtract the exponents. All right, moving on to number 12. 3 and then 2x to the negative 1 y to the fifth to the negative 2 power. All right, always we want to use the power to the power rule. So power to the power. The power to the power rule says a to the m to the n power is equal to a to the m times n. And again, we're combining it with the multiplication rule that says that inside the parentheses, all right, everything is raised to that power. So we're combining those two rules together. So I'm going to multiply every exponent inside of the parentheses. The 3 is not inside, it will not be multiplied. So 3 to the 2, or 3 times 2 to the 1 times negative 2, x to the negative 1 times negative 2, and y to the 5 times negative 2. So that's 3 times 2 to the negative 2, x to the positive 2, and then y to the negative 10. All right, the second thing I like to do is to move my negative exponents. So remember that a to the negative n is equal to 1 over a to the n. So these two factors will move, and the other two factors, the 3 and the x squared, will not. So 3x squared will remain, and the 2 to the second and the y to the 10th will drop into the denominator. And then the last thing would be to simplify 2 to the second. So this is 3x squared over 4y to the 10th. Number 13. Number 13 says an expression is shown below. We have r to the third over s to the 1/3 up to the third power. And so it says to write it in r to the m, s to the n form. So again, I'm going to use this rule, the power to the power rule, along with it's the division rule, a over b all to the m power is a to the m over b to the m. So both of these exponents will be multiplied. So that will give me r to the 3 times 3, s to the 1/3 times 3. This is r to the 9th over, here my 3's reduced and I have s to the 1st, but it does want me to write it in this form. So I'm going to have to move this into the numerator. And remember to do that, r to the 9th, well, in order for this to move up, the exponent's going to become negative, so that's s to the negative 1. All right, the last two problems on this page, and then we'll move on to the additional review that I passed out. Number 14 is the the square root of 3x cubed y cubed times 6xy to the 4th times, and then 2y, and these are all under a square root. When you're multiplying radicals, you can multiply your coefficients. So 3 times 2 is 6, times 6 is 36. So I multiplied my coefficients. X to the third and x, I'm going to add my exponents. So that will be x to the 3 plus 1, which is 4. And then y to the third and y to the 4th and y to the 1st. I will add my exponents. It's 3 plus 4, which is 7. Plus 1 more is y to the 8th power. All right, 36 is a perfect square. The square root of 36 is 6. And what you should be thinking is how many pairs can you take out of a group of 4, which is x squared? Or you could write it out like this and see how many groups of 2 will come out, which is 2. And similarly, you can repeat that method here, or you can think how many groups of 2 can you take out of a group of 8, which is 4. Finally, number 15. Number 15 is what is the simplified form of the square root of x to the 6th times x to the 10th. Remember, when you're multiplying the same base, you add the exponents. So this is x to the 16th power. And so you're thinking, how many groups of 2 can you take out of a group of 16? Which is 8 groups of 2. All right, moving on to the next review. Number 1. So recall I handed out this review as well. It says, which of the following cannot form a right triangle? And so what you need to do is you need to verify, use the Pythagorean theorem. And C is always the longest or / largest value. All right, so I'm going to substitute in each of these values. 10 squared plus 24 squared equals 26 squared. If you watched the notes, you saw that you should take out the common factor first. So I'm thinking, right, what is my common factor instead of trying to multiply these? So if I take out a 2, I have 2 times 5 plus 2 times 12, and then equals 2 times 13, and these are all squareds. Now I can divide everything by 2, and that gives me 5 squared plus 12 squared equals 13 squared, which is this is 25 plus 144 equals 169, and yes, it does. Check. All right, the next one, which is B. So A is a right triangle. We have to verify B. 9 squared plus 12 squared. Does that equal 15 squared? So again, if you watch the notes, we said take out a common factor first. So 3 times 3 is 9. And 3 times 4 is 12. And 3 times 5 is 15. And then these are all squared. And I can divide everything by 3. So that's 3 squared plus 4 squared equals 5 squared. Yes, this is a 3, 4, 5 triangle, but you can check it. It's 9 plus 16 equals 25. Yes, it does. All right, the next one, 7, 24, 25. So B is a right triangle. C, 7 squared plus 24 squared equals 25 squared. This time they do not have a common factor, so we just have to square these and see if it's true. 49 plus 576 is equal to 625, and that is true. So this one is also a right triangle. So that leaves us with D. Let's check it though and make sure that it is indeed the wrong one. So 4 squared plus 5 squared equals 6 squared. Again, you notice that every time my largest side was the one that I put in for C. That's 16 plus 25 equals 36. No, it does not. So this one is not a right triangle. All right, the next one says a square has a side length of 5. So I would encourage you to draw your square and put a side length of 5 on it. All right, if one side is 5, all sides are 5. It's a square. What is the length of the diagonal? So here's the diagonal. I can call that C since this is a right triangle. And then I'm just plugging this into the Pythagorean theorem. 5 squared plus 5 squared equals C squared. 5 squared is 25. So we get 25 plus 25 equals C squared. That's 50 equals C squared. We'll square root both sides. C equals the square root of 50, which is 25 times 2. 25 is a perfect square. It's 5. Radical 2 is irrational. It stays under the radical. And so 5 square root of 2. And the last two problems, we have square root 28 times square root 14 times the square root of 8. Before we try to multiply these to make our math easier, let's go ahead and simplify each radical. So when we simplify 28, that's 4 times 7 under our radical. And 14, there's no perfect square in it, so we'll leave it as 14. And 8 is 4 times 2. And the square root of 4 is 2. It will come out. And that gives me a square root 7. There's no perfect square in 14. And the square root of 4 is 2. So that would be 2 root 2. Now I multiply my coefficients, which is 4. And I multiply my radicands, which is 7 times 2, 14, times this 14. This is again a perfect square, so it's going to come out. So 4 times 14, and 4 times 14 is 56. All right, the last one, simplify 3 square root 50 minus 2 square root 45 plus 5 square root 18 minus the square root of 125. So before we can combine radicals, right, they have to have the same radicand and the same index. Well, they're all a square root, so they do have the same index, but we don't know if they have the same radicand until we simplify. So always simplify first. So we're going to simplify the square roots. That's 25 times 2. 45 is 9 times 5. 18 is 9 times 2. And 125 is 25 times 5. All right, now these perfect squares, they're going to come out and they will multiply with those coefficients. So the square root of 25 is 5, so we have 3 times 5 and then root 2. Minus 2, the square root of 9 is 3, so that's going to come out and multiply. The square root of 9 is 3, so that's going to come out and multiply. And the square root of 5 is 5. It's going to come out, but their coefficient there is just a 1. So it'll multiply with the 1, but it's still just a 5. So this is 15 root 2 minus 6 root 5 plus 15 root 2 minus 5 root 5. All right, when we combine these two, right, they have the same base, the same radicand, we would just only add the coefficients. This is 15 plus 15 root 2's. And the same thing here, when we combine these, we'll only subtract our radicands. So that's plus negative 6 minus 5 root 5's. And so 15 and 15 is 30 root 2 plus negative 11 root 5's. And then we would rewrite this as 30 root 2 minus 11 root 5. All right, that's the entire review. We'll have more review tomorrow. Have a good evening.